Measure airflow cubic feet per minute with the heating, ventilation, and air conditioning temperature rise formula by multiplying furnace output in British thermal units by 0.008 and dividing by the measured supply minus return temperature rise. Then use that number to flag low airflow or high airflow conditions that hurt efficiency, comfort, and equipment life. Set up the test cleanly. Run the system in heat for at least 10 minutes to stabilize. Put a fast response thermistor probe in the return plenum away from heat exchangers. Seal the insertion point. Then place the supply probe at least 18 inches downstream of the heat exchanger or evaporator coil and upstream of any humidifier bypass to avoid stratification. Read nameplate furnace output British thermal units, not input, and apply local altitude correction if you are above 2,000 feet because air density changes affect both temperature rise and combustion output. If a modulating or two-stage furnace is present, lock it into high fire when measuring maximum airflow and into low fire if you are profiling low-capacity operation. Otherwise, the calculation will be wrong. Use the furnace-rated temperature rise window as a sanity check. If your measured rise is outside that band, airflow cubic feet per minute is likely incorrect and you should pause before condemning parts. When adjusting blower speed taps, match heat and cool settings to coil pressure drop and duct static, because the correct tap in heat may be a blower speed lower than cool to maintain the listed rise without whistling registers. Confirm total external static pressure with a manometer across the furnace, filter, and coil. If total external static pressure exceeds manufacturer's maximum, your calculated airflow is probably low regardless of speed tap. Always normalize for filter condition and coil cleanliness by testing with a new filter and a verified clean coil, since a partially loaded filter can mimic undersized ductwork. Document your probe's readings, speed setting, gas manifold pressure, and stage so you can compare later after each corrective step. One of the biggest mistakes in airflow calculation and heating, ventilation, and air conditioning troubleshooting is using input British thermal units instead of output, which inflates calculated cubic feet per minute and leads to chasing a fake high airflow issue. Verify steady-state efficiency or use manufacturer's listed output to get the real number. Another common issue in airflow measurement is taking temperature rise too close to the heat exchanger or directly downstream of the evaporator coil, where air is stratified and sensors read hot or cold streaks. Relocate probes to well-mixed locations and use 2 probes averaged if space allows for more accurate airflow testing. A frequent error in airflow diagnostics is ignoring duct design and total external static pressure. Focusing only on blower motor speed, measure supply and return static pressures. Look for high return static that screams undersized or blocked returns, then open additional return grills, reduce restrictive filter media, or upsize duct trunks to bring static and airflow back into spec. BigHomeProjects.com lists verified heating, ventilation, and air conditioning contractors who know how to measure airflow with the temperature rise method. Read total external static pressure and correct duct restrictions or blower settings without guesswork. Homeowners use it to find trusted local pros with photos, reviews, and insurance verification, while contractors use it to showcase expertise, win leads, and book more airflow and comfort optimization jobs.